Hey guys, so in today's video I'm going to go ahead and go over some more Anki flashcards, and in the last video I went over Pandas as well as Scikit-Learn. At least yesterday I did two videos actually. Um, yeah, I'm just going to kind of keep doing these. These are mostly just going to be study sessions. Feel free to just skip ahead to see if you want to kind of go over something. I think I'm going to start trying to explain what is going on as far as my thought process when I look at all of these metrics, and I apologize if you can't see this because I know it's kind of small. I thought the image would be bigger, but anyways, the point or the goal for today is going to be doing more flashcards, and likewise it's just going to be a study session. So I'm probably just going to mumble sometimes as I'm trying to think out things, and I'm also going to be kind of going over a little bit of Seaborn, as I've realized that's a little bit easier than Matplotlib, especially when it comes to creating something like a box plot. I mean, how kind of easy is that? All you gotta do is call the x and the y, whereas when you're doing Matplotlib, you've got your fig and your x and all the rest. So I'm just like, I don't want to do that. I don't want to create something. I don't know. I want to get straight to the point and pretty much just kind of go. So goal for this month is to go ahead and finish out these flashcards. Well, finish just like studying them, I guess, and then also kind of go back and forth with creating RandomForestClassifier, like a classification model, and then also checking the metrics. So I'll go ahead and continue with our Scikit-Learn cheat sheet. I might hop into Pandas, and then we'll just kind of go from there. So yeah, let's just dive in. So what we have in front of us is our Scikit-Learn cheat sheet, and yesterday I left off with this question. So for a classification model, like let's say you've already kind of run through the fit, the score, and you've already like done your EDA, you've fit the model, you've evaluated it, and then you've also reviewed your cross val score as well. After performing all that, how for a classification model, how can you view the accuracy, the ROC curve, the ROC AUC score, the confusion matrix, and the classification reports? And then how can you also import each of them into their own section? So if we wanted to be able to go through to it and like evaluate the accuracy, I guess first off what we should consider is like when it comes to importing. So with regards to importing, from Scikit-Learn, you'd go ahead and do from Scikit-Learn.metrics, and then you'd be able to import the rest. So all of these are correlated to metrics. So if you were to go ahead and try to remember this, I'm trying to think of like what we could possibly use for like a moonwalking with Einstein is what I'm referencing right now, is like what I'm thinking of, and that's the memory palace technique. How would we use this with our memory palace? For those that don't know what a memory palace is, it is pretty much recalling a specific location in memory, visualizing it, and then implanting odd images into your the visual that you have that you're holding in your mind. Just implanting the odd image there, so that way it's able to be retained easier. And I guess the Greeks would actually have a lewd image. And that would really help them out, or just something kind of disturbing, shocking, something that just would really be out of the ordinary. And I can't, maybe it's because I'm not comfortable with like expressing my thoughts right now, but I'm not really, I guess, thinking of something that would be shocking or whatever with regards to like from sklearn.metrics. Like, how would you create some sort of an image that would give us this idea of a metric and then associating it with like an accuracy score or even an ROC and curve and ROC AUC score? So I guess something that does kind of come to mind is what we could do is we could go ahead and do. So I'm kind of picturing, I used to go on this walk all the time along the lake. It's something that's known as a dike or a levee, and it's like a mile long, and there's just pretty much just a ton of rocks. But I'm kind of picturing for an accuracy score, maybe we could do some guy shooting an arrow and it's going to hit, no, it's going to go ahead and hit, yeah, okay. So the thing that I just thought of would definitely work for me, but I'll kind of let you guys think about what you would want to do for an accuracy score. I'm just thinking of like an archer hitting something, and yeah, so there's that. And then we also have the ROC curve. So the next one would be, maybe I'm just thinking of a rock that's curved, and then from there it could be a rock. Oh god. Oh wow. I was thinking of like those games that you'd play where you'd have the ball and you'd roll them up to try to hit like one of the center holes. Like you have a circle, you'd have the center, the outer rim, and then another outer rim, and then it'd be like another target. So I'm thinking of that score. But I was thinking of it as if it was like a rock. So I guess that would work. As I'm kind of like thinking through this, I'm not sure that I want to actually use the memory palace for this. Like I can easily memorize this, the accuracy, the ROC, and the AUC curve score. But I think the most important part would also just be the false positive rate and true positive rate and threshold. I think memorizing this specific line would be more important. Well, so the false positive rate, true positive rate, and then threshold for the ROC curve. So FPR, TPR, and then threshold. Thresholds with an S. And then the ROC curve. And then the confusion matrix would have nothing, but something that they all have in common is a Y test and a Y pred. Y test is also known as Y true. So there's that. And then the classification report would also be the same thing. Confusion matrix, Y test, Y pred. So really the only thing that you need to kind of memorize then is from sklearn.metrics for pretty much all of these, the scores, the matrix, confusion matrix, the classification report, and then the ROC curve. And then, so they're all correlated to metrics. And then with regards to the false positive rate, true positive rate, and threshold, that would be associated with the ROC curve. So how can we think of that? FPR, TPR, and threshold. So my mind is just kind of going back to the image that I kind of had with regards to rolling, I don't know, that stone or the ball into like the different sections. Yeah, so I'll just kind of leave it there with that. But we've got our false positive rate, true positive rate, threshold. 1, 2, and 3 for R, O, and C. I guess we'll kind of just see what comes with that. But yeah, I won't really worry too much about trying to memorize like this portion at least. So I'm gonna go ahead and just kind of click on easy, and then we'll get over to like the next flashcard. And I'm just gonna play this by ear, just kind of gauging like what would work for me, because I know if like I'm kind of interested in it, then I feel like other individuals would also be interested in at least learning, or at least maybe having this on the background saying, okay, that's a kind of a good thought. So yeah. So after scoring a model, how can you evaluate a model with cross-val score? And how can you import cross-val score? And then how can you score none and score precision? So we're going to need to create 2 cross-val scores with this. So after scoring our model, how can you evaluate a model with cross-val score? So what we would do is we'd instantiate the model. So we would have a variable which is equal to random forest. So for example, if we want to instantiate the model, we could do from sklearn .ensemble import RandomForestClassifier. And then from there, what we could do is we could go ahead and do CLF equals RandomForestClassifier. And then from there, what we can do is we could go ahead and do CLF.fit. And then that'd be an X train, Y train. And then from there, we'd want to be working with the cross-val score. So Let's go ahead and leave that as pass. And then it would be from sklearn dot model selection, import crossfall score. Will that work? And then let's also just do train test split, just because we might need it, we might not. Let's just run it. And here's something that I was working on, but I'll go ahead and delete it. Working with Seaborn, and yeah. So if we wanted to evaluate the crossfall score, what we would do is we do CLF. No, what we would do is we do, so don't forget, this is as much practice for me as it would be for like someone else. But we do crossfall score, and then from there we do estimator equals CLF, because that's what we want. Like, it's going to be the random forest classifier. And then from there, our x would equal x, and then I'll go ahead and explain what x is in a little bit, and then y would equal y. And is that? Yeah, I guess it is. And from there, we would go ahead and do CV equals 5, and then verbose equals to either true or 2. Although, oh yeah, and then scoring, because that was another thing that we needed. So we would do scoring would equal none. And then the other one would be scoring equals precision. So let's go ahead and leave this one then. And we'll do cross score 1 equals blank. And then from there, it would be cross, actually let's just type it out. Or I'm going to type it out because I just kind of want the practice. So it would be cross score 2 equals crossval score. And then from there, the estimator would be CLF, x would equal x, y would equal y. And then from there, what would it be? So I'm trying to like do this in memory without actually looking at what the other code that I wrote was. So verbose equals precision? No, true, 2. Let's do true, why not? I don't really know the difference, honestly, for verbose. I don't fully know it yet, and I might not. And I'll probably repeat this in every video I create until forever. But I just know verbose can be a numeric, or it can also be true from what I've seen. And I'm assuming true might be 1, but feel free to correct me. And if you know a simplistic way of understanding verbose, please feel free to leave a comment. So after verbose, we also have CV equals 5. What else? So this is how I would go ahead and answer the, whoops, I gotta remember that. So it's right and left. So that's how we would go ahead and create, after scoring our model, how can you evaluate the model? So obviously we'd use crossval score. We'd want to make sure that we instantiate the model. And then we also maybe might want to fit it. Yeah, well, no, technically not. You wouldn't necessarily need to fit the model. But how can you import crossval score? So we did that from sklearn.metrics. No, from sklearn.model selection. Import crossval score. Although that does seem kind of odd. Like, why wouldn't this, because it is a score? Well, I guess it kind of makes sense. Then I feel what's running through my mind is if it says score, it should be associated with metrics from sklearn.metrics. But if it says crossval score, based on kind of like what the crossval means, I would understand why it would be model selection, because in essence what we're doing is we take the entire data frame, the entire data set, and then we'll take 80% of the data and it'll just kind of use that 80% as our training, which would be our x, and then our y would be the 20%, and then that would be our test. And then that's just one iteration. And then because we did CV equals 5, it'll go ahead and iterate through the data just randomly, spontaneously. So it'll take 180% of the data and then 1% or 120% of the data, that'd be 1. A different 80% of the data with a different 20% of the data, and then that'd be 2. And then another different 80% and so on. So it just kind of iterates through it, and in essence, it does return scores of different evaluations based on the data itself and the model that we're using. So I don't know. I feel like they should have named this differently, but anyways. And then how can you score none or precision? And we've done that as well right here. So with regards to the x and the y, so if we're going to go ahead and take our data frame, what we would have is we'd have the entire data set, right? So if we did the length of it, we'd be able to see what it was. And let's actually just run it then. So run it. So we've got 850 lines of code. And now the reason, actually I don't need this, but what we would do is we do x would go ahead and equal dataframe.drop, and we go ahead and drop the column that we wanted to predict. So we would drop, in our case, would be survived for the Titanic data set. Axis equals to 1 because that is the column that we're calling, 1 equals column. And we're dropping the entire column of survived. So everything except for survived is our x. And then from there, y would go ahead and equal dataframe.survived. So we would drop survived here, and here would only be survived. So yeah, that's in essence, I guess, where we get the x and the y from. If we were to go ahead and run it, and then we'll probably get an error if we run it because it's not, oh, I guess it would run. No, so we did get errors, right? Failed, yeah. So because these are not numeric values, that's why we're getting the error. But in essence, it did run, and x was associated with x, y was associated with y. So yeah, so that's just part of it. And then let's go ahead and move on to the next question. So yeah, estimator CLF, XX, YY, CV5, scoring precision. So I feel really confident in using this, so I'll go ahead and just click on easy, and then I'll practice it in 4 days. And then all that these libraries are: import matplotlib.pyplot as PLT, numpy as np, pandas as pd. These are all for exploratory data analysis. And exploratory data analysis would obviously, we would go ahead and convert string values into numeric, or drop unique values. For example, like a name or an email, I'd just pretty much just drop that because you wouldn't want necessarily someone that's named Mr. Victor in one column associated with someone else that's also named Mr. Victor, but they have two different last names, right? You'd want to make sure that your model is predicting based on a correlation of actions rather than unique values like names or social security numbers or emails even. You would want to make sure that it's focused strictly on the action itself. Like if someone buys product X, what are the odds that someone else that bought product X would also buy something else associated with the first person? That's kind of a bad analogy, but the point is you would want to create identify patterns, and that's what all the algorithms do for YouTube and Amazon and pretty much all the rest. So that's our EDA. And then, sorry if you can't see this again, I'll try to read it. So what is happening here? So when we have x equals dataframe.drop, our target column, it's pretty much what I just went over here with the x and the y. All we're doing is we're identifying what the x would be, which would be everything except for our target column. Y would be the target column. And then that's pretty much just happening here as well. And we're splitting the data. So that's pretty easy. And then from here, so this is just in correlation with the x and the y. What we would do is after we split the x and the y, we would go ahead and do numpy.random.seed 42, or you could go ahead and do pretty much you could do this. So you could do xtrain xtest, ytrain ytest, and then that would equal train test split. From there you do x, y, and test size would be 20, and then random state. Random state. If I'm not mistaken, that could be like 42 as well. So yep, random state. So all that this random state or the random seed do is it pretty much keeps the data. It keeps the data. What's it called? Keeps the data so that way if someone else comes in and runs your notebook on their machine, that they'll have the same results as you because you're using the same set of data on your machine as another person would on their machine. So you would really only need either random seed or you would need random state, and you don't need both. But yeah, we were only able to also create xtrain and xtest, ytrain, ytest, because we already called what the x data would be, and we've also called what the y data would be. So he doesn't have it here in this flashcard, or at least I didn't copy it over, but yeah, you'd want to make sure that you use call your test size as well. So it's pretty easy as well, mostly because this is all just kind of like a refresh for me. But yeah, so for this one we would instantiate our model for RandomForestClassifier, and then likewise you'd instantiate RandomForestRegressor for a regression problem. And then for those that are curious, you can just search online for a Scikit-Learn algorithm cheat sheet and then just look at the images, and then you should be able to come up with this image. And if you do click on the main website for Scikit-Learn and you are able to identify where this image is, you can then click on like any of these green sections. So you could click on a k-neighbors classifier, linear SVC. You could go ahead and click on most of these green sections, and then it'll bring you to a model that you could then learn more about. So this again is just more of the answers. So with regards to CLF.fit, we've got our xtrain and ytrain. So I believe the question to this answer, so like this flashcard that's showing in front of us is the answer. The question would be, how would you fit a model? How would you predict? How would you create like a prediction with your model? How would you create a prediction probability with your model? And then how would you view both the predictions and the probabilities of the model itself? So just know that the predictions will be on our x test, and then our fit will be on our xtrain and ytrain. And then we would use score, like clf.score on xtest, ytest. So if you're new to this, what I would advise you do is go ahead and click on the link in the description and then check out this individual's GitHub. Daniel is an individual that I learned programming from. So I would advise that you just kind of look through his notebooks and then create your own flashcards if you can with Anki, which is pretty much what I've done. So, and I've also done it for TensorFlow, PyTorch, and then just random websites like Tutorial Point. So just be creative with whatever flashcards you create. So that's pretty easy. And then this one again, we're just doing score. So if you remember hearing me say what we do for if we want to score a model, we'd obviously call x test and y test. And that one's pretty easy as well. And then this is a Crossfall score again. So we'd use model selection. X would equal x, y would equal y. So the reason that we wouldn't have xtrain and ytrain or x-test, y-test is because of our CV. So remember how I mentioned a little earlier, it would take like 20% of one data and then 80% of the other data, and then it would jumble up the data again, and then it would take a different like section of data for the training, which would be our x, and then another section for our training, which would be y. So CV allows us to not really worry about splitting the data into X train and Y train, and so on. And then the metrics again. So false positive rate, true positive rate, threshold equal ROC curve, and then they all have Y test and Y probs, and they're all brought in with metrics from sklearn.metrics. So that's easy. And then for a regression model, how can you import and find the score for R2 score, mean absolute error, and then mean squared error, assuming we're using the Boston housing data set and we've already split it. So we have our X, our Y, X train and X test. We have our test size 0.2. The only thing we don't have is np.random.seed, so we didn't seed the value, which we should do. And then we also have our model, which equals random forest regressor. So we're instantiating the model. We're going to go ahead and fit the model in X train and Y train. And then from there, we're doing our Y preds, which will be model.predict X test. So prediction and predict proba are both X test, and they both come after we instantiate our model, which would be right here. So model instantiated, fit, and then predictions, and then also predict probability. But predict probability is only for classification, if I'm not mistaken. And then this is a regression problem, so that's why I mentioned that. But now, how can you import and find the scores for R2 score and then mean absolute error? So I'm not as comfortable with evaluating regression models, but let's go ahead and dive into our Colab, and then let's just kind of dig around and see if we can do this. So let's first go ahead and import these values, R2 score and the other metrics. So if I'm not mistaken, and what I believe we could do is from sklearn.metrics, import R2. So yeah, so it would be metrics, and then I'm also going to go ahead and check mean absolute error, which it does, and then also mean squared error, which would be right here. So we'd be able to import them this way, and then from there, how would we be able to evaluate the score? So for our accuracy score, what we did is we did Y true, and then Y pred. Y true is also Y test, so we could just do Y test instead since we have it. But then when it comes to the R2 score, what would it be? So it would also be Y true and Y pred. So okay, so it would be Y test, Y pred. And then from there we'd have the mean absolute squared error, which would then be Y true. So I guess there's a similarity with the regression metrics as well as the classification metrics. So then if we went over to mean squared error, and if we did Y test, so it'd be Y true and Y preds. Okay, cool. And then if you wanted to, I'm sure you could go ahead and do like R2 score equals this. So you could like create a variable or assign them to a variable. And then for mean absolute error, we could go MAE, and then mean squared error can be MSE. So let's go ahead and see what the answer is to this flashcard. So from metrics, yep, so they're importing them from the metrics, and then it's just going to be a Y test, Y preds. So it's pretty easy. So then, theoretically speaking, the only hard one should be the ROC curve, right? Yeah, the ROC curve, because that would take a false positive rate, true positive rate, and thresholds with an S. And then that would equal Y test and Y true, Y true aka Y test with Y predictions. And in order to get our predictions, we would need Y preds equals model.predict, and then on the X test. Cool. The only difficult thing then would be of understanding what the scores actually mean, since we have 1.96 for the mean absolute error, and then the mean squared error we've got 7.75, which if I'm not mistaken, it is pretty much just a doubling of the mean error. So yeah. And then next up is how can you identify the hyperparameters of a model? So that's actually going to be really useful, and luckily I would not know the answer to this if I didn't create these flashcards like 3 days ago. But if we wanted to find the hyperparameters of a model, what we could do is we'd go ahead and do get params. So if we did clf.get params, that would go ahead and return the parameters of the model. Now, if you're confused about what the parameters are, just know that with machine learning, you can call these different metrics, aka the hyperparameters, and then you can adjust the hyperparameters so that way you're testing your model on different adjustments, and in essence, this is how you identify a better algorithm. So just for simplicity right now. So for example, if we were going to go ahead and do RandomForestClassifier, what we could do is we could do max depth, and then that could go ahead and equal, I'm not sure if it would be a list or if it would just be like metrics like this, 1, 2, 3, 4. You can always go ahead and look online to see how other individuals do this as well. So just know that if you want to find the parameters of a model, what you would do is you do get params. So yeah, so we'd have clf RandomForestClassifier and then get params as well. So that one's pretty easy. And then I think this might be another answer. So assuming we split data into X and Y and X train X test, how can you manually tune a hyperparameter from RandomForestClassifier? So, and then how can you fit and score the model? So, that would be kind of a good question. So if we theoretically, does it say manually tune them? So manually tune the hyperparameters, okay. So what we would do for manually doing this, there was also going to be another way, which I'll probably go over a little bit later, but because we want to do this manually, what we'll do is we'll do clf1 equals this, and for simplicity, I'm only going to focus on one parameter, which will be n estimators. We'll say n estimators equals, let's go 200. And for the next one, what we could do is we could do clf2 equals RandomForestClassifier, and then n estimators would go ahead and equal like 300. So that is how we could manually go through and update the parameters. And then hopefully the next flashcard will go into how we can do it with randomized search CV. So in essence, that's how we'd be able to adjust our hyperparameters manually. So we'll go ahead and click on easy, and then hopefully, yep. So this will probably be the last flashcard of the day for at least this video. I might create another video in a bit. But with regards to adjusting our hyperparameters, how can you adjust RandomForestClassifier parameters with randomized search CV? And how can you import randomized search CV? So if we're going to go ahead and adjust these hyperparameters, what we would do, make sure you split your train and test data, and then how can you fit and score? So, these would be manual adjustments, and then from there we'd go ahead and do from Scikit-Learn. The goal is to import our randomized search CV. So which one would it be? I'm assuming it's model selection. So from model selection, import randomized search CV. Does that work? Yep. Okay. So randomized search CV as well as grid search CV can both be imported with model selection. So first we'll do randomized search, and then I'll go into maybe grid search. But what we have is our goal is to adjust these hyperparameters with randomized search CV. So what we could do is we could do RF for random forest, and then we could do randomized search CV, RSCV maybe. From there we'd go ahead and do randomized search CV, and then from there it would be CLF, and then param distribution. Oh, that's right. Okay, and then okay. So let's go ahead and do this then. So let's go ahead and do random forest params, which will go ahead and equal dictionary. And let's go ahead and turn these into specific values. So let's go ahead and turn them into strings. And then from there, what we could do is we could go ahead and create a list. So we could have 100, 200, 400, and sure, 500. And you can always Google online what are the best values to use for a specific parameter. So you can go ahead and just kind of do your own research as well. Max depth, maybe 2, 1, 0, 4, 5. Max features, I don't remember what the features would be. I think some of these might also be string values. So I'm going to go ahead and look online as well, just to verify like what they might be. So what would be max features? So we have our max features. It can be set to auto. What else could we use though for max features? So it looks like we could use none or 6, but is there like a max features list of values? List of values. Maybe. So it's looking like we could use a square root of our end features, log. So it could be an int, a float, or one of these values. So it could be auto, square root, or log. So let's do auto. Let's do like auto, and then one could be like 6, and then another one could be like none, and another could be, how about sqrt for square root. And then let's also go ahead and check the min samples split. Let's search it. So it's looking like it would be an integer, but let's check one more. So it also looks like it could be like a range of values. Oh, that'd be kind of good. So we could do like, for a range, we could do, okay, sure. So we could go ahead and use a range of values, right? Yeah. And then can we do the same thing for min samples leaf? So let's see. Let's try maybe one more, like a gradient boost. So looks like he's only choosing one there. What else can we do? So we have our min samples leaf, for min samples leaf and min samples leaf. Nice. So np.linespace might be an option. And so min samples leaf is the minimum number of samples required to be at a leaf node. And this is for tree models. Yeah, let's just go ahead and use it. Endpoint equals true. And then so after doing all that, something that might be smart to do is just pretty much just copy the best features and then run your models, or like have something pre-typed up so that way you don't need to go and do your own research later on. But yeah, I'm sure you guys will figure it out as you kind of keep programming. But so we got a random forest params, and those random forest params, that variable will go ahead and be used for our param distribution. So we have our params, and then what else do we need? We've got our estimator, which is CLF, param distribution, which is the dictionary we just created. We can do niter, can be 10, and scoring we could leave as none. Njobs, I think I'll go ahead and leave that as none as well. And then should we do CV equals a certain value or no? Let's do CV equals like maybe 5. So, and then we'll go ahead and do verbose equals 2. So with regards to the niter and CV equals 5, I'm assuming that this will run 50 times if we were to run it, because it would iterate through it like a for loop, like each of these 10 times. But then because we're doing CV equals 5, we're just taking different portions of that data, and we're comparing the 80% and the 20%, and then mashing it up and checking again the 80% and the 20%, mash it up, and then 80%, 20%. And we're also doing a for loop going over each of, not each of these, but it randomly will select each of these values. And what it will do is it will just count however many values there are here. So it'd be like, we've got 4, we've got another 4, and then 4 more. So this alone would be 16 different iterations. 4 times 4 times 4, so 16 times 4 more, that'd be a 4. Carry the 2, the 1, so it'd be 64. So this would be 64 alone then, and then not considering the range. So this could be like just something kind of crazy. We would have a crazy amount of values that we could go ahead and just iterate through. So yeah. So if I was to run this, what would happen? Probably get an error. So max depth. Oh, that's right. And then numpy is not defined, so we'd also need to import numpy. So np, and we'd probably still get an error, or not. Okay. And then let's go ahead and call it. So it would be rscv for randomized search CV, and we should get an error, but we did not. Interesting. So maybe we need to do fit, so it would be xtrain, ytrain. ytrain. And then that would be xtrain is not defined. So we want to make sure we call our xtrain next test. Joy. The joys of studying. So import numpy as np. So we'll just have it twice. So now we should have it, and then from there what we could do is we could go ahead and run this. But we should also still get an error. So it'd be check the list of available parameters with estimator.getParams.keys. So that'd be something cool also. So let's go ahead and do this now. I know I'm going on a bit of a tangent, but I'm just kind of following along with where the code goes. So we would have these different keys for them. And what did we call a CLF though? RandomForestClassifier. Yeah, so it should still be our classifier up here. Yeah, so that would also still give us these same values. So we'd have bootstrap and all the others. So then we would run this and run this, we'd probably still get an error. Yep. So let's also not forget, when we do want to fit something, we want to make sure that they're all numeric values and they don't have any missing values. So let's go ahead and see what the answer would be to this. So what we did is we imported randomized search CV with model selection. We also have our grid, which is what we called over here, which would be our random forest parameters. Now they did n estimators, which would then equal this list. The max depth would be none, 5, 10, 20, and 30. For our max depth, we just did random numbers. Max features, it's the auto or square root. And then let's just get rid of none. And then from there, we have our min samples split and min samples leave. So 1, 2, 4, 6, 1, 2, 4. And in essence, I believe that we'd still be fine with just these as it is. And then from there, the estimator would be CLF, param distribution would be the dictionary. We'd have CV equals 5 or both equals 2. And then we go ahead and call fit x train, y train. And then we could print our best parameters with randomized search CLF. And then that would get our best params. And then we'd also be able to score it after that. So my guess, the reason is that this isn't working is because our data isn't actually transformed into numeric values. So always make sure you transform them into numeric values. So I'm thinking that I'm going to go ahead and call it. What I'm going to go ahead and do now is I'm going to try to remember the ROC curve, which we'd be able to have that with our false positive rate, true positive rate thresholds. And then it would also go ahead and take our y true and y preds, and then y true is also our y test. So I'm going to go ahead and try to remember those, and I'll probably create another video in maybe another hour or two after I've just kind of had a break to digest all of this. So yeah, so I'll go ahead and end this video here. If you like, please feel free to click on any of the links below. If you like, please feel free to book a Snugg session with me. I'll pretty much just go over assisting with data science. Just know that I can help out with SQL, but not necessarily like the crazy kind of stuff out there, just kind of the generic like if null or like a MySQL subqueries, or just kind of basic to intermediate type stuff, not necessarily creating tables and all that. And then we can also even probably go over like Pandas or Scikit-Learn. So I'll end this video here. Yeah, I'll just end this video here. So thanks for watching.